A wire is stretched from the ground to the top of an antenna tower as shown. It says as shown, but I'm going to draw it for you and then it'll be shown. I'll show you that in a second. The wire is 20 meters long. The height of the tower is 4 meters greater than the distance d from the tower's base to the top of the wire. Find the distance d and the height of the tower. I have no idea what that just said, do you? So what should you do? Read it again and maybe in the process draw it? Yeah. Okay, so I know we've got a wire and I know we've got a tower. I'm not going to get very fancy. There's my tower, right? If you're not told otherwise, you assume flat ground. Here's my flat ground. What kind of angle is the tower going to form with the flat ground? A 90-degree angle. Okay, I'm forming a triangle so that I can use Pythagoras' theorem. So the wire is stretched from the ground to the top of the antenna tower. I can do that. So the wire is going to be somewhere over here. The wire is used to help hold up the tower, isn't it? So the wire is going to be somewhere on the ground, and it's going to stretch to the top of the tower, and that's going to complete my triangle, isn't it? Yeah? Okay, let's see if we can label this appropriately and then find what it is they're asking us to find. So the wire is 20 meters long. Oh, so that thing in green I just drew is 20 meters. I can draw that, right? The height of the tower is 4 meters greater than the distance d from the base of the tower to the bottom of the wire. Oh, well, what do they mean by the base of the tower? Where it touches the ground, right? And then the d distance, in other words, they're telling you what to name the unknown. You could call it x if they didn't tell you. It's 4 meters greater than the distance d from the tower's base to the bottom of the wire. Oh, here's the bottom of the wire. Here's the base of the tower. That's the bottom of the tower. Here's the bottom of the wire. They're telling us that that distance from here to here is d. You got to read this stuff slowly or you're not going to know what it says. And take the time to draw the picture. Remember, Paul used 4 steps in problem solving. Read, understand the problem. If necessary, draw the problem to help you understand it. And then I think we can label the other side in terms of d now. The wire is 20 meters long. The height of the tower is 4 meters greater than the distance d from the tower's base to the bottom of the wire. It's saying that the tower is 4 meters greater than d. How do I write that in symbols? So the height of the tower, that's just this guy, right? So isn't that going to be d plus 4? Does everybody agree with that? So read it again. The height of the tower is 4 meters greater than the distance d. Oh, that's d plus 4, isn't it? So you got to take your time with this to understand the problem. Does everybody understand the problem? Find the distance d and the height of the tower. Well, it's too bad we don't have a theorem that would relate those 3 values, right? Oh, wait, we do, don't we? Pythagoras' theorem. What does it say? Yeah, okay, a squared plus b squared equals c squared. What does it say in terms of these values here in this right triangle? Yeah, it really says the sum of the squares of the 2 shorter legs of that's what they called it, the short sides of the triangle is the legs. The sum of the squares of the legs of the triangle. So that's, in this case, that's d squared plus the quantity d plus 4 squared, isn't it? Equals the hypotenuse squared. The sum of the square of the legs equals the long side squared. Or the sum of the squares of the 2 shorter sides equals the long side squared. And what's the long side? 20, so you got to square that. That's Pythagoras, isn't it? Everybody agree with that? That's a polynomial equation, you guys. It's one we should be able to solve. Let's take a time out and write down some of the steps we learned in the previous problems that we did. Okay, we've got to set this thing equal to 0. So we've got this equation, d squared plus d plus 4 quantity squared equals 20 squared. Okay, we could simplify the 20 squared, make it 400. Yeah, you're expected to do that. But ultimately, we want to get it set equal to 0, don't we? So, all right, well, let's work towards that result. So yeah, I mean, d squared plus the quantity d plus 4 squared, you could, first of all, make the 20 400. That's what you get when you square that out. But before I subtract 400 from both sides, what could I do on the left side? Yeah, ultimately, I want to do that. I want to subtract 400 to get 0 on one side, don't I? But what should I probably do first so it's not too messy? But if I want to factor it eventually, I've got to combine all like terms, don't I? Which is going to involve that 400 subtracted. But in order to combine all like terms, I need to multiply out that d plus 4. So you're going to, if there's something to multiply out before you factor, you're going to have to do that normally. Okay? So let's multiply out d plus 4 quantities squared. How fast can you do it? Speed's not the most important thing, but it is of the form a plus b quantities squared, and we do have a formula for multiplying that out. Remember that formula says, okay, d is the first guy, 4 is the last guy. That formula says, it says square the first guy. Isn't that d squared? And then you multiply the first guy times the last guy and double it, right? Add that in. So what does that give you? 8d, 4d times 2, 8d. And then you add in the last guy squared. What is that? 16. So yeah, if you're going to want to factor the left side eventually and set it equal to 0 first, you're going to want to multiply that out even before you set it equal to 0. Now when you subtract the 400, you have something to combine it with, the 16. So let's subtract the 400 from both sides. Remember, so this is what we're working towards, the first step. So subtract 400, and what do we get? Okay, now can I combine these two d squareds first of all? Yeah. In fact, I get 2d squared if I do that, right? And then 8d, and then what's 16 minus 400? Minus 384? 384. So step one, big old check mark. We set it equal to 0 after some simplifying, right? Okay. Now, before I factor it, is there something we can do first? Or I suppose it could be thought of it as in the process of factoring it. What? The GCF. So you could factor out there's a 2, right? When it's a constant, there's an alternative. You could divide through by 2, both sides of the equation. But if you want to be consistent with what I've done in the past, we could just factor out that 2. That'll work. So we're beginning the factoring process. We're beginning step 2 if you think of it that way. So 2 times, what's left if you factor out the 2? D squared plus 4d, and then what's 384 divided by 2? So minus 192. Everybody agree with that? Equals 0. We're not done factoring it. 3 terms on the inside of those parentheses, so reverse FOIL. Let's try it. Okay, so 2 parentheses. The good news is we have a 1 in front of the d squared inside the parentheses, so what are the 2 first multipliers going to be? D and D. The bad news is 192 is kind of big, right? So break out your calculator, take out 192, just punch it, forget about the negative, punch in 192, try numbers like 8, 12, 16, do that division, and see if you can come up with 2 numbers whose product is 192 and whose sum is, or difference is 4. So you already have 16 and 4? 12. Okay, that makes more sense. 16 and 12. So what did you do to get that?
I divided 192 by 16.
And you got 12, and you realize the difference between those 2 is 4, so that's going to work. How did you know to look for the difference between those 2?
Because of the 40.
Well, yeah, and also because it's a minus right here. Yeah? So you're going to want two numbers whose product technically is negative 192 and whose difference is positive 4, right? So use your calculator to help you out. So you said 16 and 12. Now, which one has to be minus? You know one of them has to be minus. Which one? You got to get a positive 4. It's got to be a minus 12 and a plus 16. Okay, we're done with step 2. We factored it. What do we do now? Apply the zero product rule. Oh, in other words, set both factors equal to 0, right? You ignore the 2. That's not going to help you. Setting that equal to 0 will not be true, and it won't help you. So either d plus 16 is equal to 0, or d minus 12 is equal to 0. So if you solve both of those, you get a kind of, one of them is a ridiculous answer. If d plus 16 equals 0, what's d? Okay, is that going to be a relevant answer here? No. And then the other one that's going to work is d equals 12. So that's the one you're going to take. But that's that distance from the base of the wire to the base of the tower. You also want the height of the tower. So what's the tower height going to be? Tower height. So 12 plus 4 is positive 16. So we did step 3 and 4 all in one. We set the factors equal to 0, solved. It's an applied problem, so we should probably answer the problem using a complete sentence answer. I'm going to say the distance from the base of the tower to the wire on the ground is 12 meters, and the tower is 16 meters tall. It doesn't have to, you could use your own words, but that's one way to say it.